Hi, everybody. Welcome to lesson 2, where we get a little bit more legit than the last lesson was in terms of content. Last lesson should have been a breeze of just writing fractions. And today we're going to keep writing fractions too, but they're going to come from two-way tables, which we've seen before. So this is a quick overview of how two-way tables work. So the school board of Waldo, a rural town in the Midwest, is considering building a new high school, primarily funded by local taxes. They decide to interview eligible voters to determine if they should build the new high school to replace the current one. So a two-way table below shows how people register, how every registered voter in Waldo responds to the interview. So this is called a two-way table because I'm looking at two categories. I'm looking at their age, and I'm also looking at their support for the high school. So there's two categories that I'm looking at here. And the way that we read this table is this 61 means 61 people said yes that fall in this age range. 53 people said no that fall in this age range. That's how these two-way tables work. And a lot of the times we care about the totals. The marginal totals are what these are called. So let's go through and find what's in our margins, the ends, the sides of the table to represent the totals. And the way that we do that is we just add them up. So to get this row total here, you add up everybody from that row, 75. To get this next one, we add up everybody from this row. So 9203, I think. I'm checking on a calculator because I don't trust myself. 203. This next row, how many 41 to 65-year-olds were there? There's 149. And 66 and older, 33 plus 53 plus 2 is 88. And now this box here on the bottom side, represents the total, the complete total. So the total not broken down by any category. I interviewed 515 people. This is the grand total of how many people. Those are my row totals, but I could also find column totals. So let's go through and do that. How many people said yes? I'm going to go through and add up those four numbers there. 61 plus 113 plus 66 plus 33 is 273 people said yes. 14 plus 84 plus 79 plus 53, 203 of these people said no. 230 of them said no. And I don't need a calculator for this one. 6, 4, 12. 12 people did not respond. So that's how we fill in two-way tables, is we kind of find our row totals, and these values here need to add up to the margin. So based on the survey, do you think they should recommend building the new school? Well, how many people said yes? What is the probability of yes? What's the chance of me getting someone who says yes? 273 out of 515, which is approximately, that fraction's beautiful, but what is that about? This is about 53% of the people said yes. So that's a pretty good number there, that 53. They should go and build this because 53% of the people support the new high school. A person is picked at random. If this person is 21 years old, so I know they're 21 years old, I'm not picking out of everybody. That becomes my denominator. I know this person's 21 years old, so they're from this category here. They're from that first row. I'm only looking at values from this first row. Do you think they would support building the high school? Well, how many people from that row support the high school? 61 out of 75. So let's get a decimal representation for that. It's got 81%. So do we think that a randomly selected 21-year-old is going to support the high school? I'd say yes. There's about an 81% chance that that person supports building the high school. And eligible voters picked at random. If this person's 55, do we think that she's going to indicate that she wants the new high school built? So they're 55, so what am I looking at? I know I'm picking from these people here. So my denominator, that 55-year-old, my denominator, I'm only picking from those people. How many people said yes? Only 66% of people said yes. 66 people out of 149, which comes out to be about 44%. Do we think this person's going to be likely to support the high school? Probably not. probably not going to support the new high school. They could, 44% of them do, but probably not going to support the high school. Describe the relationship between age and support. Well, we can just see based on this table. As these people get older, what happens to their support? Their support decreases, right? As I get older, I'm less likely of wanting to spend taxes because maybe I don't have kids in high school anymore. So as age increases, support's becoming less. As age increases, we see that right here. 81% of that group said yes, but only 44% of that middle age group there said yes. So as age increases, support appears to be decreasing. Does age cause support to decrease? No. I can't say because I'm another year older that caused me to not support the new high school. There's an association between them. There is an association. It's not causation. There's an association. An association between age and support. There's an association between them. So while interviewing the town about support for the new high school, gender was also recorded in addition to age. Finish the two-way table here. So I'm going to give you a second, pause the video, and see if you can find these missing pieces by kind of just adding things up and subtracting things. See if you can find those missing pieces. So let's see what we got here. Well, right away I can figure this box out. This plus 274 needs to give me 515. So 515 minus 274 is 241. Which now lets me finish up this row. I can now get this purple box. Well, I have 119 and 6 people already. These two guys make 125, but I have to get to 241. So that means I need 116 people in that box for that to happen. Well, this box isn't bad. 6 plus what is 12? 6. I have 116. I got to get to 230. 230 minus 116 is 114. I didn't pick a new fun color for that. It's a galaxy box there. Ooh, 114. How many females yeses are there? Well, there's 274 females. 6 of them didn't answer, and 114 said no. So that leaves me with 154. And now I can finish that up there. 119 and 154 make 273. So it's like a little puzzle filling in an incomplete two-way table. You just have to start adding and subtracting things up so that the rows and the columns work out. What is the probability that a randomly selected voter supports building the new high school? So what is the probability of yes, that they support the high school? Well, we found this already. 273 out of how many people were there in total? 515. I'm looking at everybody here. So 273 out of 515 was 53%. If the randomly selected voter is female, so notice I'm only picking from the females. What is the probability that she will vote to build the high school? So look what we're doing here. We're still finding the probability that they're going to build the high school. But I was given extra information about this person. I was given this person is female. So I'm only allowed to look at this female row. That's what my universe has shrunk down to. I'm not picking out of everybody. I'm only picking from the female voters. So my universe shrunk to 274. That's the total of this universe that I got shrunk to because I was given that I was only picking a female voter. What's the probability of yes? Well, I'm stuck in that row. How many females said yes? 154 females said yes. 154 out of 274 is 56%. So 56% of females, of the females, 56% of them will vote yes. That's what I wanted to say there. What if I knew they were male? what's the probability they want to build the high school? So I'm still building the high school. I'm still finding the probability that they want to build the high school, but I was given bonus information that I'm picking a male. So my universe shrinks again. I'm only allowed to pick from the male row. So 241 goes on the bottom. How many males are there? 119. Said yes, right? I'm stuck in this red row. So 119 of them said yes out of the 241. So 119 out of 241 is 0.49, so about 49%. I'm rounding a lot here. About 49%. So did knowing the gender affect the probability of the voters supporting the high school? It did. Overall, it was a 53% yes. But if we break down and give us extra information about the people who we're picking, if I knew I'm just looking at the female subgroup, 56% of them do. But if I'm just looking at the male group, only 49% of them do. So did knowing the gender affect the probability? Yes. There is an association. There is an association between gender and support. Being male or female does not cause you to support or not support the high school. There's an association between them is what we're going to say. You got one more problem and we're done with this lesson. These probability lessons aren't that bad. So health officials in Milwaukee, Wisconsin were concerned about teenagers with asthma. There's too many words, unfortunately, to read here. In a local research study, researchers collected data. Great. Students in high school completed a survey that was used to begin this research. Based on this survey, the probability of a randomly selected student having asthma was 0.193. So having asthma happens about 19.3% of the time. Students were also asked if they had at least one family member living in their house who smokes. The probability of finding someone who has someone who smokes is 42%. So the probability of someone smoking in their household is 42.1%. The probability that a randomly selected student has one member smoking and asthma is 12. So asthma and smokes is 12.0%. So what we're going to do is we're going to make a hypothetical 1,000 two-way table. I don't know how many kids are in this Wisconsin school, but I'm going to assume there's 1,000. And then I can pretend like I have 1,000 kids in this two-way table. So how many kids have asthma? Well, 19.3% of 1,000 would be 193. So has asthma overall is 193. That came from right here. I multiplied it by 1,000. Well, wait a minute. If 193 have asthma, how many don't have asthma? We can fill in that missing piece. 807 don't. I did subtraction there. 42.1% of them have someone who smokes. So 421 goes there. So how many people have someone who does not smoke? What's a smoke-free household? Would be 579. Again, I subtracted. I'm using these probabilities to pretend I had 1,000 people. And then they told me smokes and asthma is 120. Smokes and asthma is 120. So now we can fill in these other values here by subtracting. We get 73, which I think I can do this in my head. I get 506. And then doesn't matter which way you go, you end up with 301. So that's how we can fill in a two-way table. From these three probabilities, I can fill in all 8 of these boxes. So a randomly selected student has asthma. I know this person has asthma. The probability of something given they have asthma. I know what I'm doing. I know the student has asthma. That's a given piece of information. What is the probability that they have someone who smokes in their house? So my universe has shrunk to only looking at the students who have asthma. So 193 goes on the bottom. Well, how many of them smoke of this row? Not the 73, the 120 do. So if I find a percentage for that, 120 out of 193, I get 62.2%. So I was given that they have asthma, so I wasn't picking from everybody. I was only picking from that row. A randomly selected student does not have asthma. So I was given no asthma. What's the probability that this student has someone who smokes in their household? So smokes given no asthma. Now I'm looking at this row. I'm looking at the 807 over smokes. How many people in that blue row smoke? 301 have someone who smokes in their house. So it's 301 out of 807, and I end up getting 37.3%. So that given information limits your universe. So you're not picking out of everybody. You're only picking from that row or a column. If I told you that they smoked or didn't smoke, I could have switched it around. Do you think there's whether or not a student has asthma is related to whether or not a student has someone who smokes? Well, everyone who had asthma, 62% had someone who smoked in their house. Just looking at the people who don't have asthma, only 37% of them. So there is an association. There is an association between smoking and asthma, between smoking in home and asthma. It's much more likely that someone smokes in your house if I know you have asthma. So there is a relationship between those. We can't say it caused it, but we can say there is an association. I'll see you in the next lesson, and then next week we keep on practicing this too. So these two-way tables are not going away anytime soon. Bye, guys.